Imagine a massive orchestra comprised of an infinite number of stars, planets, and moons, all moving in unison to create a harmonious symphony. However, there is one particular area within this group that has baffled cosmologists for an extremely long time: exoplanets. These planets are hidden away somewhere in the Milky Way, outside of our solar system. You might be shocked to learn that there are exoplanets that remarkably resemble Earth among the enormous number of cosmic objects. As with any exciting sci-fi journey, the plot takes an unexpected turn. Experts utilizing the James Webb Space Telescope found something startling about Proxima b, a signal so peculiar that it caused ripples across the educational sections on networks. The signal was dubbed a probable technosignature. It was so complex and well-organized that it might point to the existence of a highly advanced civilization. The heartbeat of mankind seemed to pause at the peak of an exposure that held the potential to alter our understanding of reality. Is this signal the strongest proof yet that there is life on Earth? And as quickly as it appeared, the signal vanished without emerging again, leaving behind a maze of unsolved mysteries and widespread conjecture in addition to an oppressive quiet. Was it just a fleeting natural hallmark, the product of celestial events, or was there another purpose behind it all, like a signal from a disturbingly advanced culture or a coded message? This unique trip raised questions about Proxima b and sparked intense debates over whether it was a one-time anomaly or a part of a much more complex record than we could have ever imagined. There are still unwritten chapters in the record, which is a wound around a work of art that is up to our endless evaluation. This time, a shift in viewpoint in the quest for extraterrestrial life is being led by Harvard experts rather than just regular researchers. By converting the James Webb Space Telescope into a sort of massive night vision telescope, they are broadening the reach in addition to examining the signs and signals we have already analyzed. As they search for artificial light sources in both the bright and weak regions of far-off universes, they may be able to detect regular kinds of bright cities or other urban places that glow but need to be defined. Imagine being able to view the bright beams of a city that might be teeming with advanced civilization, extending out into the great cosmic oceans. The search for alien life assumes new dimensions as we work to uncover the mysteries of the cosmos. Past the fleeting fascination with Proxima b, our massive search delves further into the vast, enigmatic reaches of space. This endeavor is motivated by a deep curiosity about our place in the universe as well as innovative breakthroughs. Numerous exoplanets with potential for habitability have been found as a result of ongoing advancements in cosmology and space research. Our capacity to identify and investigate these far-off worlds has increased because to tools like the James Webb Space Telescope, JWST, and ground-based observatories. The hunt for biosignatures, or traces of life, is one particularly interesting area of research. These signs may include atmospheric gases such as carbon dioxide or methane, which may, under some situations, be indicative of life activity. Beyond mere finding, the JWST's sophisticated equipment are able to measure exoplanet atmosphere composition with unprecedented accuracy. Through examining light passing through the atmosphere of an exoplanet, scientists are able to identify artificial indicators characteristic of life. For instance, the existence of ozone or oxygen atoms in addition to water vapor may indicate the presence of conducive conditions for life. In addition to the ongoing hunt for technosignatures, another line of inquiry is to examine the conditions on these far-off worlds. These are indications of highly developed civilizations, which could be seen in man-made structures or cutting-edge technology. Megastructures like Dyson spheres, hypothetical structures made to harness the energy of stars, or odd patterns in radio waves could all fall under this category. The quest for technosignatures may lead to evidence of extraterrestrial intelligence as our observational techniques improve. In addition to creative breakthroughs, international collaboration is crucial in the search for extraterrestrial life. Our capacity to explore space is increased when space agencies, academic institutions, and commercial companies work together. Various nations contribute to missions to Mars and other celestial bodies, combining resources and knowledge to accomplish common objectives. The voyage necessitates public engagement and education, as the enthusiasm around space exploration propels scientific research and educational initiatives in the future. These programs inspire young people to seek professions in space science and spark their interest in STEM subjects. The development of new technologies also advances our understanding of the cosmos. The advancements in computational models, data processing, and telescope design enhance our capacity to locate and examine far-off exoplanets. Modern space telescopes, such as the Habitable Exoplanet Observatory, HABEX, and the Extremely Large Telescope, ELT, for instance, promise to provide more in-depth studies and insights on the possible habitability of exoplanets. Every new finding that pushes the boundaries of our understanding raises fresh queries and research directions. Finding alien civilizations is only one goal of the hunt for extraterrestrial life. Another is to learn more about the origins and possible diversity of life in the universe. It broadens our understanding of what it is to be alive and questions our preconceptions. The domains of exoplanet research and extraterrestrial life discovery are dynamic and ever-evolving. We are getting closer to finding the answers to some of the most important questions that humanity has ever posed with every step. The possibilities for discovering new life and comprehending our place in the universe are limitless as we continue to explore it. They are both startlingly similar and perplexingly different. It could be the gigantic twin of our planet. We enter the intriguing world of 4.2 light-year distant Proxima b. Our quest to solve these cosmic riddles is shaped by the James Webb Space Telescope. Imagine for a moment that your thoughts traverse the enormous and majestic Milky Way, the home of over 1 quadrillion exoplanets in our universe. To put this figure into perspective, consider that if every exoplanet had the size of a grain of sand, we would have enough to fill the Grand Canyon and establish a second, far larger landmark on Earth, known as Grand Canyon 2.0. The most astonishing fact is that 20% or so of these celestial worlds have been compared to Earth in terms of its environments and terrain. This indicates that the likelihood of discovering a twin planet to ours is 1 in 5. Moreover, the narrative does not end here. There may exist another quadrillion moons in addition to these planets, tough satellites like to our own moon that are in gravitational dances with their parent planets. The cosmos is full of opportunities if you are able to locate a body in space that is home to life, or may someday do so. After describing the size of this cosmic tapestry, let's introduce the masterpiece. The James Webb Space Telescope, a device made to highlight all of its intricate features. With its remarkable focal length, this beautiful Sherlock Holmes outperforms even the most sophisticated Marfan optics. We are not referring to any lens. It is 2.7 times larger than Hubble, measuring 6.5 meters in primary mirrors. Imagine the smallest detail. It can study the specifics of planets in orbit and detect the tiniest flicker of a star billions of light-years distant. In addition to its remarkable visual capabilities, the James Webb Telescope is revolutionary because of its state-of-the-art equipment, such as spectrographs and forward sensors. These devices are capable of far more than just observation. They can also determine the air conditions, density, and even mass of celestial objects by analyzing and filtering the distinctive light fingerprints that they emit or reflect. They can ascertain whether a planet contains oxygen, water, or organic substances by taking on the role of space investigators. By providing answers to these queries, the James Webb Space Telescope transforms from an ordinary observer into a brilliant scientific instrument. It's more akin to a quantum jump than just an advancement over Hubble, its predecessor. If you were astounded by Hubble's discoveries, get ready for a real onslaught of cosmic revelations when we extend our perspective over the wide cosmos. In the big spectacle, it's important to pay close attention to Proxima b. This strange planet has been regarded as a Shakespearean tale since its discovery in 2016. Its intricate details and secrets have captivated astrobiologists and space scientists alike. What makes a difference? Primarily, Proxima b is located in our galactic neighborhood at a distance of only 4.2 light-years from Earth. To put that into perspective, you would arrive in less than 4 years if you could travel faster than the speed of light and exceed the universal speed limit. That's about how long it takes for your favorite show to go into repeats. Let's examine this proximity's significance in more detail, though. Finding a planet this close and thus promising for scientific study is like finding a jewel in a pile the size of Mount Everest, a pearl that may hold insights about life itself. Keep in mind that the universe extends more than 93 billion light-years from one end to the other. Proxima b is a multi-layered mystery in the vast scheme of the universe that provides important hints that may change our understanding of habitability and extraterrestrial life. Scientists are intrigued by Proxima b not only because of its closeness to Earth, but also because of the intriguing signs indicating that this planet may be Earth 2.0 rather than just Earth-like. Proxima b is pleasantly situated in what astronomers refer to as its parent star's habitable zone, an environment that is just suitable for liquid water to exist and is neither too hot nor too cold. Envision cascading waterfalls, wavy rivers, expansive lakes, and potentially oceans as enigmatic and profound as the Mariana Trench. But before we begin daydreaming about visiting Proxima b, there are a few things to take into account. For example, one day on this lovely exoplanet lasts for an incredible 11 Earth days. Envision sunsets that prolong throughout the next day, gradually refusing to give way to midday and dusk, resulting in lengthy hours that would make any photographer envious. Even while it sounds wonderful, there are significant effects on the environment and habitability of the area. In what ways might human biorhythms adapt to Proxima b's light and dark cycles? On that planet, would we have to eat 3 or more times in one day? Would we sleep on this very different Earth in the same way? The essential components of life, as we know, it would be both profoundly alien and seductively similar. It seems like nature is testing our theories about what constitutes a habitable planet by presenting us with a riddle wrapped in a mystery. You may be wondering how we can collect trustworthy and accurate information about a place we have never been to. Like a massive Swiss Army tool, the James Webb Space Telescope brings all of its capabilities with it. It is a sophisticated research facility located in the vacuum of space, not merely a telescope. Space scientists are able to watch planets and study them using a suite of scientific instruments that would make CSI labs seem like amateur projects, all made possible by technology. The Webb Telescope can examine the light that these far-off planets send and reflect by using sophisticated spectrographs. Every atom or molecule in the atmosphere of a planet emits or absorbs light at a certain frequency. By concentrating on these patterns, specialists are able to conduct a distant biopsy of celestial bodies, identifying elements necessary for life, such as water, organic carbon molecules, and even oxygen, in addition to air pressure and density. It's space forensics, not simply cosmology. We actively seek out signals, studying the atoms and molecules that make up these intricate worlds, rather than waiting for them to come to us. The Webb Telescope is more than just a telescope. It is a highly specialized research facility that combines the roles of a cosmic investigator and an expert. It enables us to transform our ideas about what might exist beyond our blood into strategies for verifying or refuting our theories and hypotheses about extraterrestrial worlds. The adventure is only getting started. Even when you believe you have discovered the most enigmatic threads in this enormous cosmic tapestry. As we approach the brink of unbounded discovery, the James Webb Space Telescope serves as a ray of optimism and advancement. Its potent tools are made to probe the smallest characteristics of far-off planets, exposing parts of the cosmos that were previously inaccessible to humans. Our exploration of the furthest reaches of space is made possible by the JWST's capacity to study exoplanet atmospheres, which provides insights into the possibility of life existing on these planets, as well as the conditions under which it might arise. The possibility of finding biosignatures in extraterrestrial atmospheres is one particularly intriguing feature of this research. These biosignatures, which include particular atmospheric gases or chemical compositions, may function as markers for life activity. For instance, the presence of gases like as oxygen and methane together may indicate biological activity, since these compounds are frequently produced by living activities on Earth. These faint signals in the expanse of space can be picked up by the sophisticated spectrographs on board the JWST, providing a new window into the possibility of extrasolar life. In addition, the hunt for exoplanets has made us aware of a wide range of planetary systems, each with its own distinctive features. In binary star systems, which are made up of two stars orbiting each other with complex gravitational conditions, certain exoplanets have been discovered. Others revolve around red dwarf stars, which resemble our Sun but are potentially colder and have habitable zones.